back, boys and girls. My name is Nicole Harris Knudsen, and we're here today to look at fractions. Today, we're looking at division by a fraction. So, our learning target for today is, at the end of this lesson, you will be able to divide a fraction by a fraction, but you'll also be able to solve problems using the algorithms developed. We want to recall the number sentence for division. We are looking at the dividend divided by the divisor gives the result of the quotient. That word divisor will be used very often in the lesson, so let's remember what it means. The reciprocal of a fraction. When we talk about a fraction, if the fraction is 2/5, then its reciprocal is 5/2. What we are saying is the numerator becomes the denominator and the denominator becomes the numerator. Some people say the fraction is flipped. Let's also think the product of a fraction and its reciprocal. So an example being 2/5 multiplied by 5/2. The result will be 1. We are saying that for each whole divided by a unit fraction, the result is the total number of unit fractions that form the whole. Let's look at the examples we have been given. When the whole is divided into halves, the number we see on the diagram is the count of the number of halves. So when a whole is divided by 1/2, we see 2 halves. When one whole is divided by 1/4, the whole has 4/4. We can count 1, 2, 3, 4. Again, the count is what is shown on the diagram. One whole divided by 1/5, there are 5 parts, 5 equal parts. The count 1, 2, 3, 4, 5. The whole divided by 1/10. There are 10 equal parts. We can see the count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. And finally, our final example, when the whole is divided by 12. We see there are 12 equal parts, each part being 1/12. The count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So just casting, we see that when the whole is divided by a unit fraction, what is the result? The total number of unit fractions that form the whole. Hence, one whole divided by a unit fraction is equal to the number of unit fractions needed to form the whole. And when we think of number, let's think about the count. So let's see what we have when we're dealing with multiple wholes. I'd like us to look now at our resources. So we are familiar with what we call a fraction whole, and we can see how the whole is divided into different size fractions. Remember, when we name the fraction, it is because the parts are all equal. When we have halves, thirds, fourths, fifths, sixths, eighths, tenths, twelfths, sixteenths, it means these 2 parts are equal. These 3 parts are equal, these 4 parts are equal, etc. With the example that we'd like to look at, how about when the whole is divided by halves? Now, we're looking at 3 wholes divided by a half. So I'm thinking of 3 divided by half. I use this for you to identify the whole. Now I'm going to remove it. 1 whole, 2 wholes, 3 wholes, all divided into halves. How many halves are there? Doing a count. 1, 2, 3, 4, 5, 6. This means 3 wholes divided by 1/2 gives a result of 6. There are 6 halves. Another example. What about when 3 wholes are divided by quarters? Again, I use the whole for you to see the comparison, but I can remove it now so we understand 1 whole, 2 wholes, 3 wholes. What are we dividing by now? We are dividing by fourths. So we are 4 fourths in 1 whole, 4 fourths in the second whole, 4 fourths in the third whole. So in the 3 wholes, how many fourths are there? Let's do the count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 fourths in 3 wholes. 3 divided by 1/4 gives the result of 12. And let's get one more example. This one here is where we have 3 wholes divided by fifths. Again, we see what the whole is like, and now we see what wholes are like when divided into 5 equal parts. This is our first whole, this is our second whole, and this is our third whole. Each has been divided into 5 equal parts, so 3 is divided into fifths. Doing the count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 3 wholes divided by 1/5 gives us 15. So let's take what we have, 3 divided by 1/2, 3 divided by 1/4, 3 divided by 1/5, and let's generalize. What we can see is when 3 is divided by 1/2, we saw how we got 6. When 3 is divided by 1/4, we see how we get 12. And when 3 was divided by 1/5, we see how we get 15. Since we are generalizing, it means when we divide by the unit fraction, it is the same as multiplying by its reciprocal. So then 3 divided by 1/10 will be 3 multiplied by 10. And when 3 is divided by 1/12, the result will be 3 multiplied by 12. So we come back for multiple wholes. When divided by unit fraction, the result is a multiple of the total number of unit fractions, which form the whole. So, did you notice that when we divide by the unit fraction, it is the same as multiplying by its reciprocal? We spoke about reciprocal earlier. The reciprocal of 1/2 is 2. 1/2 is a unit fraction. 1/4 is a unit fraction. Its reciprocal is 4. 1/5 is a unit fraction. Its reciprocal is 5. 1/10 is a unit fraction. Its reciprocal is 10. And 1/12 is a unit fraction. Its reciprocal is 12. So again, dividing by the unit fraction is the same as multiplying by its reciprocal. And our example shows us 3 is converted to an improper fraction, 3 in the numerator, 1 in the denominator. Division by 1/2. Division by the fraction is the same as multiplying by the reciprocal. The division symbol changes to multiplication, and the half, the reciprocal, is stated as 2 in the numerator, 1 in the denominator. So simplifying, 3 multiplied by 2 is 6, and 1 multiplied by 1 is 1. 6 over 1, 6 in the numerator, 1 in the denominator, speaks of 6. So let's look now at when we take different numbers and divide by the unit fraction. This time, we're choosing 1/4. So the diagram shows 1 whole. 1 whole which is divided by 1/4. The numbers at the top tells us the count. So one whole has 1, 2, 3, 4 fourths. Let's look at this. Let's start with 1/2 divided by 1/4. We have divide the whole into 2 halves. So 2 equal parts, 2 halves. Since there are 2 halves in one whole, let us shade the half we wish to divide. So one of the halves is shaded. Now, let us divide the whole into fourths. We have taken the same whole. We can identify the 2 halves, but if the whole is divided into fourths, we are speaking of 4 equal parts. We can see all the 4 equal parts identified and labeled as fourths. We can count how many fourths the shaded half has been divided into. We have 1 and we have 2. The shaded half has been divided into 2 fourths. So our answer would be 1/2 divided by 1/4 is equal to 2. So we are back to what we had earlier. Students, dividing a number by a unit fraction is the same as multiplying the number by the reciprocal of the unit fraction. 1 divided by 4, it's the same as 1 multiplied by 4 over 1. And the result is 4. So let's see how that goes. Let's go back to our board. So we looked at 1 divided by fourths. We looked at 2 divided by fourths. Now let's see what is 1/2 divided by 1/4. So this is my whole, and I can get 2 equal parts. 1/2, the second half. Let's focus on dividing this half by fourths. There are 1, 2 fourths. So then 1/2 divided by fourths gives us a result of 2. So can we generalize? Do we see that 2 divided by fourths, it's the same as 2 multiplied by 4 over 1? 4 then divided by fourths will be 4 multiplied by 4 over 1. And 8 divided by fourths will be 8 multiplied by 4 over 1. When I say 4 over 1, we're speaking of 4 wholes. If we have looked at the whole numbers and we have looked at the fractions, we did look at 1/2 divided by 1/4. So it will be the same if we are following the pattern. 1/4 divided by 1/4. Well, how many times will 1/4 be divided into itself? 1 is a reasonable answer. It is the correct answer. 1/8 divided by 1/4. Again, 1/8 multiplied by the reciprocal gives us 1/2. So back to the beginning, we are saying, we are confirming, dividing a number by a unit fraction is the same as multiplying the number by the reciprocal of the unit fraction. So what happens when the divisor is not a unit fraction? Remember I mentioned the term divisor before. The dividend divided by the divisor gives us the result, which is the quotient. The divisor would be the number, the fraction that comes after the division sign. What happens when that number is not a unit fraction? So let's consider when 1 is divided by 5/6. 5/6 is not a unit fraction. What is it? If we divide the whole into sixths, then we need to get a group of 5 to determine 5/6. So 1, 2, 3, 4, 5 will form one group, but there's one left over from the set of 6. We're going to call that the remainder. So now we are focusing on grouping. How many are in a group? There are 5 in a group. in total, the whole is to be divided by 5/6. But one group gives us 5. There is one remaining because there was 6/6 in a whole. So we have a group of 5/6 and we have a remainder of 1/6. 5/6 are needed to form a group, but 1/6 remains. We need to account for that remainder because we need to get a result for this division. Let us consider the remainder of 1/6, and we are going to compare it to the group. The group has 5 parts because there are 5/6, but the remainder is 1 part. If the remainder is 1 part out of 5, then it must be 1/5 of the group. It means then the whole has been divided into one group with a remainder of 1/5. The group is the 5/6. Hence, 1 divided by 5/6 gives us 1 and 1/5. But we can go further with this. What about what we tried earlier where we said dividing by a fraction is the same as multiplying by its reciprocal? So if we are dividing by 5/6, we worked on multiplying by the reciprocal using unit fractions. 5/6 is not a unit fraction, but it does have a reciprocal of 6/5. 1 divided by 5/6 should be the same as 1 multiplied by its reciprocal, which is 6/5. Working out the numerators or simplifying, 1 multiplied by 6 gives us 6, and 1 multiplied by 5 gives us 5. So we have 6 in our numerator, 5 in our denominator, 6/5. But 6/5 is the same as 1 and 1/5. Wasn't that the original result we got? Yes, it was. So what do we see? Dividing by a fraction is the same as multiplying by its reciprocal. So let's see what this looks like using a model. First, we divide the whole into 2 halves. And because there are 2 halves, let's shade the half we wish to divide. Now let us divide the whole into 6. We need 5/6, which are more than 1/2. So this problem here is where we're dividing 1/2 by 5/6. If we can see that 1/2 is less than 5/6, the same as 5/6 are more than 1/2, then reasonably we should expect a result which is a fraction. What is being divided is smaller than what we are dividing by. Do we see that in order to get the 5/6, we need 5 parts? The half only provides 3 parts. So when we divide a half by 5/6, there are 3 of the 5 equal parts. That's all we have. So 3 of the 5 equal parts, how do we express that as a fraction? That must be 3/5. So 3 out of the 5 gives us a result of 3/5. So let's put it all together. We worked out 1 divided by 5/6. Remember, we got 1 and 1/5. We worked out a half divided by 5/6. We just got 3/5. So we are seeing that if we take the number and we are dividing it by any fraction, then it's the same as multiplying by its reciprocal. We have a few other examples. 1/5 divided by 5/6. Again, 1/5 multiplied by 6/5. Simplified gives us 6/25. 1/10 divided by 5/6. It's the same as 1/10 multiplied by 6/5. When we simplify, we get 6 50ths, and reducing even more, we get 3 25ths. How about when we take whole numbers and divide by 5 6? 2 divided by 5 6. Again, we multiply by its reciprocal. 2 multiplied by 6 fifths. The result, 12 fifths. And now we can write 12 fifths as a mixed number. When we divide 12 by 5, we are going to get 2, with 2 parts remaining, 2 and 2 fifths. On to 5 divided by 5 6. We want 5 multiplied by 6 fifths. Our result, 30 fifths, which gives us a whole 6. And finally, 10 divided by 5 sixths. We get 10 multiplied by 6 fifths. This gives us 60 fifths, which can be written as 12. So we see that whole numbers can be divided by fractions, fractions can be divided by fractions, and whenever we divide by a fraction, it is the same as multiplying by its reciprocal. So clearly, dividing a number by any fraction is the same as multiplying the number by the reciprocal of the fraction. But we have met different types of numbers. We have met whole numbers, we have met fractions, we have met mixed numbers. Do you recall a whole number can be written as a fraction? Do you also recall a mixed number can be written as a fraction? So for an example, let's take a whole number. A whole number, 7, can be written where 7 is in the numerator, 1 is in the denominator. The fraction, 7 wholes. The mixed number, 9 and 3/8, can be written as 75/8. How do we get 75/8? 9 multiplied by 8 in the denominator gives us a result of 72. 72 added to 3 in the numerator gives us a sum of 75. 75/8. So, if we were asked, what happens when the divisor is a fraction? Once I say divisor, what else comes at you? Recall, a number sentence with a dividend divided by a divisor gives a result, a quotient. Then when I think divisor, I must be speaking of the division operation. Dividing by any fraction is the same as multiplying the number by the reciprocal of the fraction. Let's go on to problem solving. When we problem solve, we have to consider our 4 steps. We have 4 simple steps we will use. The first, understand the problem. The second, devise a plan. The third, carry out the plan. And the fourth, check the solution. What do we do if we are to understand the problem? We need to read the problem carefully. Having read the problem, can you state the problem using your own words? How about if you underline the key words? You need to identify what information you are given. And you need to ask yourself, what am I being asked to find or to show? What is there that is unknown? With step 2, when we devise a plan, we need to ask, is the problem similar to another problem you have solved before? What if it's not? Well, you need to be creative and formulate a plan. So what are some of the strategies you can use? You can look for a pattern. You can guess and check. You can use objects. Maybe draw a picture or a diagram. Use your logical reasoning. And we're going to be doing some of that here today. Make an organized list or make a table. Act it out. Work backwards. Use a number sentence. Solve a simpler problem. Step 3, how about when we carry out the plan? Then, whatever plan you have decided on, use it to solve the problem. Check each step of your solution carefully. Can you see clearly if each step is correct? Can you prove it? Do not be afraid to start over or change the plan. Give yourself a reasonable length of time to solve the problem. Step 4, check the solution. Is the answer reasonable? Can you work backwards and check the answer? Was all the relevant data used? Data, information, facts. Were all your facts used? Are the appropriate units of measure stated? Let's look at a problem. Ms. Muraj is preparing medals for graduation. She has 18 3/4 meters of ribbon. She ties each medal with 5/8 of a meter of ribbon. How many medals can she prepare for graduation using the ribbon she has? So, remember those 4 steps? Let's see if you remember. Understand the problem. Devise a plan. Carry out the plan. Check the solution. So let's understand the problem. She has 18 meters of ribbon, but she needs to divide that ribbon into smaller parts, into fractions. What's the size of a fraction? 5/8 of a meter. When she divides the ribbon into 5/8 of a meter, we can count how many pieces there are. That will tell us how many medals she can prepare. Let's get to it. We need to solve Let us first convert the mixed number to an improper fraction. Remember we said earlier a mixed number can be written as a fraction. How do we do that? 18 multiplied by 4 gives us 72, and 72 added to 3 gives us 75. So we have stated how we are going to make the conversion. You can do this mentally. If you do, you will get 75/4 divided by 5/8. Recall that dividing by a fraction is the same as multiplying by its reciprocal. So, change the division symbol to multiplication and multiply the reciprocal of the divisor. What's a divisor? 5/8, the fraction that comes after the division symbol. 75/4 are now multiplied by 8/5. Now, let us remove common factors from both the numerators and denominators. Take our time here. I want to start with the numerator 8 and the denominator 4. They both have a common factor of 4. So, 4 divided by 4 gives us 1, and 8 divided by 4 gives us 2. The other numerator is 75. The other denominator is 5. 75 and 5 do have a common factor, which is 5. So, 5 divided by 5 gives us 1. 75 divided by 5 gives us 15. Let's continue. It means then 15 multiplied by 2 is our result in the numerator, and 1 multiplied by 1 is our result in the denominator. 15 multiplied by 2 is 30, and 1 multiplied by 1 is 1. Our answer would be 30 medals. So, remember those 4 steps? Go back to the problem. Have we understood the problem? Did we devise a plan? Did we carry out the plan? And did we check our solution? Did we pay attention to our units? How many medals can she prepare for graduation? Our answer states the correct unit, 30 medals. Let's move on. Problem number 2. Pat studies 4 hours daily from Monday to Friday. She studies 2/3 of an hour during each session. If she studies 6 subjects, how many sessions does she spend per week on each subject? I look at the problem, and that's a whole lot of information. We have hours, we have days, we have subjects, we have sessions, we even spoke about a week. There's quite a bit of information there. So we really must understand what is it we are looking for, what is it we have been given. Pat studies 4 hours daily from Monday to Friday. That's given at the beginning. What are we being asked? How many sessions does she spend per week on each subject? We are looking at the week as Monday to Friday. We have to get that information here. We were told nothing of Saturday. We were told nothing of Sunday. We are talking about Monday to Friday. We have to be able to deduce we are talking about 5 days. So let's get to carrying out our plan. The total number of hours from Monday to Friday would be 4 multiplied by 5. 4 hours per day, 5 days per week. But the length of each session, we are told, is 2/3 of an hour. What does that mean? All that time, those 20 hours, need to be divided into bits of 2/3 of an hour. We're looking at division. Let us first convert the whole number to an improper fraction. "20 wholes divided by 2/3. Recall, dividing by a fraction is the same as multiplying by its reciprocal. So we change the division symbol to multiplication, and we multiply by the reciprocal of the divisor. What's a divisor? It's the fraction that is coming after the division sign. That means we want 20 wholes multiplied by 3 halves. Now, let us remove common factors from both the numerator and denominator. In this case, 2 and 20 both have a common factor of 2. So, 2 divided by 2 gives a result of 1, and 20 divided by 2 gives a result of 10. Go on, multiply numerator by numerator and denominator by denominator. 10 multiplied by 3 gives us 30. 1 multiplied by 1 gives us 1. 30 wholes which we can simply write as 30. That tells us how many sessions are needed to be divided among 6 subjects. So when we took all our hours and we divided them into 2/3 of an hour, where 2/3 of an hour was 1 session, we see how many sessions in all we have to work with. So Pat has 30 sessions to work with, but she has 6 subjects. So what does Pat do? Pat divides these 30 sessions among the 6 subjects, and that leaves her with, we're dividing sessions by how many subjects. Think of what our unit would be. Our unit will be 5 sessions can be used for each subject. What's our answer? Our answer is 5 sessions. So, go back to the problem. Pat studies 4 hours daily from Monday to Friday. She studies 2/3 of an hour during each session. If she studies 6 subjects, how many sessions does she spend per week on each subject? Understand the problem. Devise the plan. Carry out the plan. Now, check. Is our unit correct? Remember, there were so many different units in there. We had days, we had sessions, we had hours, we even spoke about a week. Our unit, 5 sessions. Our answer. Let's move on. In our third problem, Corey uses 1 3/8 meters of wire to build a fuse. Fuses are packaged in boxes of 4. How many boxes can Corey fill if he has 20 5/8 meters of wire? So, we need to understand the problem. Most of the words are familiar. How about that word fuse? Well, if we think of fireworks, the fireworks would need a fuse to detonate. Do you remember how much fun you have at Independence Time, at New Year's, with all those fireworks? We're using fuses. But Corey is using wire to build fuses, and that's what we're working on today. So the terms in the question need to be familiar. Students, I cannot say how much literacy is important for solving our problems if we must understand the question. A reader is a leader. So, fuses are packaged in boxes of 4. How many boxes can Corey fill? We speak about fuses. We speak about boxes. We speak about meters of wire. We have some information there. Let's put it together. We first need to solve 20 5/8 divided by 1 3/8, because all the wire that Corey has needs to be divided into lengths of 1 3/8 for each fuse. So let's first convert the mixed numbers to improper fractions. 20 5/8, 20 multiplied by 8, added to 5, divided by 8. 1 3/8, 1 multiplied by 8, added to 3, again divided by 8. We keep our denominators. In this case, coincidentally, both denominators are 8s. We can simplify. We have 165 8s to be divided by 11 8s. Recall that dividing by a fraction is the same as multiplying by its reciprocal. Change the division symbol to multiplication and multiply by the reciprocal of the divisor. We then get 165 eighths multiplied by 8 elevenths. Now, let us remove common factors from both the numerators and the denominators. 8 is a factor of 8. It appears in both the numerator and the denominator. 8 divided by 8 gives us a result of 1. And again, 8 divided by 8 gives us a result of 1. Now, maybe it's simplified, but if we really want to simplify, we must continue to check as we work through our problem. 165 and 11, do they have a common factor? Yes, they do. The common factor, 11, is a prime number, so we're not going to find any number smaller than 11, which is a factor of 11. Let's see. 165 and 11, they do have a common factor of 11. 11 divided by 11 is 1, and 165 divided by 11 is 15. So we can simplify our numerator, 15 multiplied by 1, and our denominator, 1 multiplied by 1. 15 wholes, we simply write 15. What does that tell us? It tells us that we can get 15 fuses from 20 and 5/8 meters. One box must contain 4 fuses. So those 15 fuses we have, we must divide into groups of 4 for each box. 15 divided by 4. 15 divided by 4 gives us 3 wholes. 3 fours are 12. 12 from 15 is 3, a remainder of 3. So 15 divided by 4 as a mixed number, 3 and 3/4. What does that tell us? We can get 3 boxes, but there are 3 fuses left over. 3 boxes can be filled, leaving a remainder of 3 fuses. What is your answer? 3 and 3/4. So tell me what you think your answer is, because we need to check, did you answer the problem? Is your answer 3 boxes? Let's go back to the problem. Corey uses 1 3/8 meters of wire to build a fuse. Fuses are packaged in boxes of 4. How many boxes can Corey fill if he has 20 and 5/8 meters of wire? How many boxes can Corey fill? Can he fill 4? No, he has 3 and 3/4. Can he fill 3? Yes, he can. We need to know how many boxes, which is a count of the number of boxes he can fill. Our answer cannot be a mixed number. Our answer is 3 boxes. What's the algorithm we have been using all along? Dividing by a fraction is the same as multiplying by its reciprocal. Let's read the question. Let's work it out. A school's choir sold 15 frosted chocolate cakes at a cake sale. Each cake was cut into 8 slices, and 3 slices were packaged per box. How many boxes of cake were on sale. Ian says he can solve 15 divided by 3/8 for the answer. Lee says he can solve 15 divided by 8/3 for the answer. Which boy is correct? Explain your reasoning. So, students, we need to understand the problem. What is being asked here? Are you going to answer how many boxes of cake were on sale? That would be part of your answer. But that's not what you really need to know. What you are being asked, which boy is correct, and explain your reasoning. That would be the response to this question. Your answer must include the name of the correct boy and your reason for selecting that boy. So, we have three numbers, 15, 8, and 3. 15 represents cakes, 8 and 3 represent slices. How did Ian come up with that answer? How did Lee come up with that answer? Maybe we need to work it out for ourselves to see which one is correct. Then we can check if they're correct. Let's use our reasoning. So, each of the 15 cakes was cut into 8 slices. So we can find the total number of slices. How will we get that? 15 multiplied by 8. I won't go on to working it out. I'll go further. Now, 3 slices were packaged per box. So we must divide the total number of slices into sets of 3 to calculate the total number of boxes. If the total can be calculated using 15 multiplied by 8, that's what we're going to divide by 3. But 15 multiplied by 8 divided by 3 can also be written as 15 wholes multiplied by 8 over 3. So boys and girls, all the mathematical ideas we have learnt all along the way, we are using them now to reason out this problem. We are looking at Ian and Lee, but they took the problem and they wrote it using the operation of division. We've worked so far, but we've only come up with multiplication. Is there a way that we can somehow rewrite our problem so now it looks like a division problem? Well, that algorithm we've been looking at so far, we speak of dividing by a fraction being the same as multiplying by its reciprocal. And here is where we use our understanding of language. Look carefully. Does this also mean multiplying by its reciprocal is the same as dividing by a fraction? Yes, it does. And we can state that. So, if that is true and we can state it, let's do it. What are we multiplying by? We know dividing by a fraction is the same as multiplying by its reciprocal. That multiplying by 8/3. Those 8/3 would be the reciprocal. So if 8/3 are the reciprocal, what's the fraction? You got that right. If 8/3 is the reciprocal, the fraction must be 3/8. So we can write 15 wholes divided by 3/8. Did we see that before? Yes, we did. That was Ian's solution. let's check back. Ian says he can solve 15 divided by 3/8 for the answer. Lee says he can solve 15 divided by 8/3 for the answer. Ian got the answer we got using reasoning, logical reasoning. Ian must be correct. So that's one way. Let's look at another way you may do it. And this is why when we are learning anything, we want to understand the concepts. Because when we understand the concepts, we can use them any way we wish, using logical reasoning and sound mathematics to solve our problems. Let's look at one way you may have done it. So again, going through the question carefully. A school choir sold 15 frosted cakes at a cake sale. Each cake was cut into 8 slices, and 3 slices were packaged per box. How many boxes of cake were on sale? Ian says he can solve 15 divided by 3/8 for an answer. Lee says he can solve 15 divided by 8/3 for an answer. Which boy is correct? Explain your reasoning. So, let's look at working out this plan instead. Each of the 15 cakes was cut into 8 slices. So, find the total number of slices. We get 15 multiplied by 8, giving us a result, a product of 120. 3 slices were packaged per box. So, divide the total number of slices into sets of 3 to calculate the total number of boxes. 120 divided by 3 gives us a result, a quotient of 40. The answer is 40 boxes. Is that what we were asked? Or were we asked, was Ian or Lee correct? So with our understanding, we figured out how many boxes there should be. But we need to answer the question, which boy is correct? And we need to explain our reasoning. So how many boxes of cake were on sale? We got that. Let's see how we can use what we got to explain which boy is correct. So, since Ian's solution came first, let's work with Ian's solution. Ian's solution says solve 15 divided by 3/8. So first convert the whole number to an improper fraction. 15 wholes are divided by 3/8. We know dividing by a fraction is the same as multiplying by its reciprocal. So we are multiplying by 8/3. So we work this out. We want to simplify and remove any common factors in our numerator and our denominator. 15 and 3 both have a common factor of 3. So 3 divided by 3 is 1. 15 divided by 3 gives us 5. We can write 5 multiplied by 8 divided by 1 multiplied by 1. 5 multiplied by 8 is written in the numerator. 1 multiplied by 1 is written in the denominator. Simplify 40 wholes or 40. Did we see that before? When we used Ian's response, we got the same as when we worked it out ourselves. We should know that our calculation is correct because we used all our steps. We understood the problem. We devised a plan. We're carrying it out. So if we did all of that and checked, our 40 boxes are correct, and so would be Ian's. Therefore, Ian must be correct because his method also produces the correct answer. So if this were your answer, it would be perfectly correct. The question is about Lee. Students, we are talking about understanding our concepts. 3/8 and 8/3 are not the same value. If 15 is divided by 3/8 and 15 is also divided by 8/3, I'm leaving you to work that out yourself. You will not get the same answer. So we worked out Ian's answer, and it was the same as our correct answer. So our correct answer would be Ian is the one with the correct solution, and you have seen how you can explain your reasoning. So, boys and girls, when we are doing our problem solving, it's really good that we can find algorithms to help us. But we have to remember that our algorithms come from ideas which we must understand. I've heard of a nice little KCF which is used when we are dividing by fractions. You know what I mean. Keep it, change it, flip it. That works well. But how about when we have to explain our reasoning? When we must explain what we understand in the problem? Algorithms are useful. Understanding our concepts are better. So, just to summarize today's lesson, simple. Dividing by a fraction is the same as multiplying by its reciprocal. Yes, we can use an algorithm, but it's better if we understand the concept. Boys and girls, this ends today's lesson. I thank you for viewing. Keep watching